Okay, so a couple things before we do this example. Now, one of the things about the definition of a basis that you want to be aware of is that it's talking about a sequence of vectors. Okay, so that's different than what we've been talking about prior to that, which is, or what we've been talking about are a set of vectors. Okay, so a couple of things to keep in mind. When we talk about a basis being linearly independent, we're talking, we know that it's going to be linearly independent if the multiset consisting of those vectors in the sequence are linearly independent. And we also would say that the basis spans the vector space if the set of vectors in the sequence span the space. Okay, so it's a little different than what we've been dealing with because we're talking about a sequence, and remember, a sequence order matters. Okay, so it's not like what we were talking about before with sets. Okay, so now, for example, this is a basis for R2. Okay, it is literally independent, right? And how can we see that? We watch. Okay, so we set up our linear relationship, right? Our linear association. So it's going to be C1 24 plus C2 1 equals 0, right? So that's going to give us our linear system. And so what do we get? We get 2C1 plus C2. And here we get 4C1 plus C2. Oops. And what do we get? Well, when we do the row operations, we get we're going to get C1 equals C2 equals 0. Right? You can see that because if we get rid of this, multiply this by -2, we get rid of this one, we get -2 here, and then what do we get? We get -1 equals 0. -1 C2 equals 0. So C2 is going to equal 0, and then here, yeah, it's just going to be the same thing. So you can see that it's just going to be 0. So that tells us it's linearly independent, right? It also spans R2. Because again, if we take our relationship, right, and we talk about any xy, right? So instead of, So instead of 0, 0, we're just going to take any vector in R2, right? That would just be xy. Okay? And so what do we get? Well, if we do the same thing, we get what? We get C1 or excuse me, C2 will equal yeah. So if we do the same thing, this goes away, we're going to get -1. Yeah, so we're going to get -2x added to this. So we're going to get negative, so, okay, let's do it in 2 steps. -C2 is going to equal what? Y minus 2x. And of course, if you multiply by -1, you'll get that. So 2x minus y. Okay, so that's going to be C2. And then, of course, by back substituting up here, what are we going to get? We're going to get C2, or excuse me, 2C1 plus C2, which is 2x minus y equals x. And so if we, hold on a second. Yeah, that's right. And so if we solve for C1, what do we get? We get C1 equals x minus 2x plus y, which equals y minus x. And of course, oh, this is 2. So then we're going to divide by 2. And so we get C1 equals this. And so we can see that we can find a C1 and a C2 that will make it work. Yeah. So we can define C1 and C2 for any value of x and y. And so that shows us, like before, that shows us that it spans. So this sequence of vectors also spans R2. So that is a basis by definition.